All right, guys. Well, welcome to the second week of the intermediate pipeline. If you weren't here last week or you don't know, my name is Harper. I will be running the intermediate pipeline for this quarter and for next quarter. And this week, we'll be going over a little bit about data visualization and how to do that in Python. Just some general announcements before I get started. We'll be talking about visualizations today. But for those of you who are new to the club and aren't really familiar with how the pipelines work, our beginner pipeline is for those of you who have relatively little experience with coding or maybe aren't ready to do a full-on data science project yet. So if you have only taken maybe like AP Comp Sci and have never seen Python before, recommend you check out the beginner pipeline. That'll probably be useful to you because they'll be going over lots of more basic concepts when it comes to Python, how to load data sets, how to create basic visualizations, things like that. And our advanced pipeline, which is the project pipeline, is for those of you who want to get started on a project and maybe want to find other students to work on those projects with you. So if you have taken some data science courses before, maybe you've done like PSTAT 134 or 131 or doing those right now, I highly recommend that you'd go to the project pipeline and try to do a project. The best way to learn is by doing, and I definitely encourage you to do a project, even if you think you might not be super qualified to do so. And if you're not sure, you can always come back here. All of our materials will be posted in the Intermediate Pipeline Slack. If you haven't joined that already, please do so because all of our materials will be posted there. So quick recap for last time, we went over just some basic data science principles, the workflow of creating a project, the entire pipeline, the goals of machine learning, how that can be useful for us in a data science project, and a couple of the different kinds of machine learning. So classification, unsupervised, supervised learning, things like that. And we briefly touched on the train and test setting concept, which it's not something you really need to worry about right now, but definitely keep it in the back of your mind for the future, because that will be important if you're ever working on a supervised learning kind of project. So right now we're at the stage of the project where we have our data set and we need to figure out exactly what to do with it. If you notice, we're in this explore area of the pipeline, but we did skip a couple of steps, and that is because a lot of methods for exploring data with Python actually do incorporate some element of data cleaning already. So some of what we'll be doing will already incorporate some of the data wrangling for you, which is nice. So before we go into the technicalities of it, why do we visualize data? That's a question we all need to ask ourselves. And at its core, visualization is a way to convey the properties of data in a way that humans can understand. So unfortunately, human beings are not very good at interpreting large data sets. We just don't have that kind of cognition. And visualizations are a way to sort of explain what's going on with data in a way that we understand. Kind of like using standardized measurements like mean and median to describe data. Visualizations are a way to help us digest what exactly is going on with the set that we're looking at. What these four graphs represent right here is something called Escombe's quartet. And basically what's going on here is that each of these distributions is its own data set. Each of these four graphs represents a different data set, but the caveat is each of these data sets has the exact same mean and median. And when you fit a linear regression model to them, they produce the exact same model. Obviously, though, Each of these sets is very different in terms of their distribution, and it's just an example of how standardizations like visualization and using mean to describe your data set can be very misleading, because obviously these are not similar at all. Like I said, visuals are one of the ways that people misconstrue statistics the most easily. And what I mean by that is it's very easy to change people's opinions about what they're looking at based on how you scale your visuals. And in this case, just a small adjustment to the way the y-axis is fitted changes the meaning of the data entirely. It makes it seem like there's a trend that's more significant than there may actually be. There are some examples of visualizations that are just really terrible. For example, this image is not really conveying anything of importance to us. It's very colorful and it does contain a lot of information, but other than that, someone looking at this for more than like less than 5 seconds couldn't really discern any pattern or meaning to it at all. So there's that. There's also overcomplicating your visualizations. If anything, using visuals to describe your data is a way of simplifying it for your audience, and this is not the way to do that. And then in some cases, there are just visualizations that are blatantly incorrect. Another way to sort of explain why this would be important is through this example. And this is sort of a game, if you will. It's called the game of 15s. So in this case, 2 people would be playing against each other, and the name of the game is to choose 3 numbers that add up to 15 before your opponent does. And in this case, one person would, for example, pick 9, and then maybe the other would pick 3. And then on the first person's turn, again, they would pick 5. And if you were logically in the place to counter this person, your natural answer might be to pick 1. And since this kind of computation is not efficient for people to do, having to calculate all these different numbers is very time consuming, and on larger scales is really complicated. We simplify it to a means of visualization that's easy for us to understand, and that's essentially how we end up with this sort of tic-tac-toe like thing. We understand that each row in each column in this matrix actually adds up to 15. So if you take any of the numbers on the diagonal axes or the rows and columns, they'll actually add up to 15. And that's the concept of tic-tac-toe, right? If you get 3 in a row, you win. So this is a concept that comes from actually this professor at NYU who's done a lot of coursework on data visualization and data analysis with an emphasis on visualization. So it's pretty interesting if you ever want to look him up. This is kind of an example from the first lecture that we did, where we had 2 different series of data on the X and Y. And in this case, it's pretty easy for us to tell that there's a linear correlation between these 2 features, as you can see. But for human beings, when we introduce some element of noise to our data set, as you can see here, not as easy to tell what the distribution might be. But by using graphs, we can obviously create a way for us to recognize that, yes, there is probably a linear correlation between these 2 variables, even with the element of noise. And just so you guys know, if you ever have any questions at any point, just like shout them out. That's perfectly fine as well. So just to reiterate, visualization is a way for us to identify different features of our data that we might not otherwise be able to. If we were just given like a massive data set of rows and columns, we might not be able to tell, like for example, what all this would mean. Sometimes it can also let us know which features of data are important to look at, and that's also something we might not otherwise be able to discern. So today we'll be going over one package of Python in particular called Altair, but there are also different tools that we can use for visualizing data. And a lot of it depends on your domain. If you are working on a project within a specific domain, you might want to think about using specific tools that might be best suited for what you're doing. For example, neuroscience might use a couple different packages that you might not otherwise be able to make good use of. I don't know too much about it myself, but these things do exist. For geography, there's this thing called GIS, which is great for visualizing like landscapes and like spatial data. And this is something you'll probably see like if you're going into business or anything on a corporate level. In terms of data, you might be using something called Tableau, which you can see a little bit of right here as well. This might be something that's a little more familiar to some of you, but just to go over it because this will be important for the notebook that I'll be releasing later. It's the concept of different kinds of features, nominal, ordinal, and quantitative features. So we have a data set here. This is our standard structured data set, something that's very cleanly laid out. This is from the Titanic data set, which we introduced last week. As you can see here, all of our different passengers are labeled with an index per row, and all of their individual features and categories are listed at the top. Nominal features are, I guess, another way of saying categorical features, which, in which case the order of the data doesn't matter. So for example, different features like hair color or like species type, these things don't have a specific order to them. They're just categories. Ordinal features are a little different. They're like categorical features, but their order actually is important. Ordinal, order, it's easy to remember. For example, in this data set, the passenger classes 1 through 3 are actually an ordered set. So obviously 1 is above 2 and 2 is above 3, and it's a pretty strict order, and that's why this would be considered ordinal feature. There's a good article on the difference between these two at this link. If you're interested, I'll post the slides later and you can check this out. And finally, quantitative features are just numbers, things where we're keeping track of a numerical value to describe something, the price of a house, for example, square footage, height, weight, things like that, all quantitative features. And now that we've briefly gone through what types of data exist in these cases, we'll also go over the types of visualizations that we can create to address these different features. And first and most familiar to all of you probably is the concept of bar charts. Everyone's done these before. They're very familiar. And this kind of visualization would be most useful to you if you were working on a categorical variable. In this case, the type of movie that you like. And from this kind of data, you would be able to tell a quantity associated with each category. Histograms are similar to bar charts, but aren't exactly the same. In this case, instead of a categorical variable, you're working with quantitative variables. So something with a specific number. If you're evaluating the distribution of a certain variable, you might want to create a histogram of it. You might be able to get some sort of clue as to what kind of distribution you're working with if your data is adhering to some sort of parametric value. Box plots are another thing that you've all probably seen before. These are used for analyzing quantitative variables also. But in this case, we're basically getting a summary of how our data is distributed. You can see in this case that we have a our interquartile ranges laid out for us. Our outliers are also presented at the ends, and that's a good way of identifying how everything is spread. Line graphs are for using when you have data that takes place over periods of time. So for example, if you're using time series data, you would probably need to use a line graph to describe the data. This essentially shows how your values fluctuate as you pass from one period of time to the next. Another interesting kind of visualization that I want to convey to you guys, because it's less commonly used, is correlation heat maps. And the way this works is you can essentially identify correlations between different features in your data set without exactly being able to tell just by looking at, say, a table like this. So from this, you would hardly be able to tell anything on its own. But in terms of correlation, obviously the areas with higher correlation will be very clear to you based on coloration. There's a lot more to go over too. With Altair specifically, there's a lot of documentation that you can look for just to see what kinds of plots are in that package specifically. Another Python visualization package that you'll probably use, especially if you're doing classes, is matplotlib. Also very useful for visualizing. If you know how to use these two packages, you'll probably be pretty well off in terms of data science as a whole. Again, lots of different visualization tools out there. But like I said, the big ones are probably matplotlib and Altair. And I think there are a couple of other ones that get used a lot, like Seaborn. Seaborn might be another one you might be using at some point. But we won't be going over that today. So. And finally, we move on to Altair, which is our package of interest for today. We'll be using this more in the notebook that we'll be going over later. The creator of Altair is this guy named Jake van der Plas. You've probably seen this name before, mainly because he's the author of this data science handbook, which is actually, let me see if I can find it. This one. He's the author of this handbook, which you might actually use for class at some point. It's very useful for coding in Python. But yes, he's currently an engineer at Google and the creator of Altair. He's also worked on both NumPy and Matplotlib too. So if you want to look at the source code for Altair, it's on GitHub, readily available. Again, you can check it out when I give you the slides later. We'll run through the basics of how to use Altair. It's not too different than other visualization packages you've probably used in the past, especially if you're familiar with R and you've used things like ggplot or anything like that. Basically, we'll call the package with ALT, which is just the abbreviation for Altair. Pretty standard Python etiquette. And our function takes as a parameter a pandas data frame, which is really useful. Since we'll be using data frames quite frequently for our data sets. Unlike other packages or other languages that you may have used in the past, we actually specify what type of plot we want after calling in our data frame. And these are just a few listed here that might be interesting to you. For example, if you want to use a bar plot, it's just mark_bar. pretty straightforward. Different kinds of things where you might get like a line plot here, for example. Like I said, it would be useful for you to browse the documentation just so you can get a sense of what kinds of things might be available to you. And finally, we'll pass in all of our other parameters, depending on what we want to visualize. So for example, in this particular bar chart, we are trying to observe the number of passengers in each of the three classes: first class, second class, third class. And by doing so, we would pass our P class parameter, which is the feature that describes each of our passengers' class, into the Altair X value, and the count of that feature using the count function for Y. Pretty straightforward. And last but not least, I will leave you with this. Basically, this is an interesting quote that I thought was funny, but visualization is, I guess, the way for someone who's observing data to convey the results to the general population. And I cannot stress this enough, that visualization is important, because you may have the most sophisticated and refined models or something out there that you've ever done, but it won't mean anything if you can't convey what the result actually is. So in a sense, learning how to visualize data effectively is very intuitive. It requires you to know your domain very well, and it also requires you to understand how people who are not very familiar with statistical theory or anything like that would interpret things and be easily misled by certain things. So I'll go ahead and put these in the Slack right now, but these are just the links to like the slides and the notebook I have up here. I'll go ahead and do that now. Just another thing to add, if you guys had any questions on last week's notebook, feel free to stick around. I'll be here after this presentation just to like answer questions if you have anything. If you have questions on this notebook, definitely come and ask too. I'll be going over it briefly next week.